In this episode, I'm going to look at a 120 watt sub amplifier. This is a mono sub amplifier by NHT. It was brought in. Client says it's not working properly, so we're going to take a look at it and see what the problem is and see if we can get this one working. So let's get started. This is an NHT SA amplifier. This is a mono monster. And I've been told that it's not working or not operating correctly. So before I even connect it, let's pull the top off it. And for those wondering what this is for driving a subwoofer. This is a subwoofer amplifier. Mono. Set up for just bass. It's basically a big Class B or Class AB amplifier. Features a 2SA 1302 and a 2SC 3201 output transistors. Big beefy transformer. It's got a dual primary on this one. There's a little switch back here to switch for 110 or 115 or 230 volts is what it's set for. Set for 115. So basically what that will do is when you throw the switch the other way, it will put the windings in series. Right now, the way it's wired, we've got the hot wire going directly into the transformer, the neutral wire coming back going to neutral, but in this mode. But if you throw the switch, it then puts it through the second winding. Looks like both windings might even be in parallel at this point. I was looking at the way the wiring is on this thing. Anyway, it's a dual primary so that it can operate on dual voltages. On the back, you've got terminals, speaker terminals, and outputs to your speakers so that if you don't have a line level output, you can drive it right from your speakers. So left and right input, and then these go out to your main speakers, and then your subwoofer goes onto here. If your amplifier does have a preamp out, you can connect your preamp to here, and it's also got line out that would just pass back to your main amplifier. So your preamp would connect into here, and then this one would connect to your main amplifier if you have a preamp out. If you don't, you just use the speaker inputs and outputs, and then of course the subwoofer output. So as to say, I have no idea whether this works or not. We're going to hook it up. We're going to find out. And try not to blow my speakers. Oh, look at this. We've got a cap here that's looks to be a little bit in distress. So I'm going to say right offhand, it's probably going to need at least a couple caps replaced in it. If that is actually leakage, which it does look like this one's leaking. So that's probably what is wrong with this thing here, is some of these caps are in sad shape. It's also got the brown glue or the yellow glue that's turned brown. And it looks like we may even have a short down here if we look down close here on the board. Yeah, look at the bare wire there. This is really kind of piss poor manufacturing, if you ask me. What's that for? That's just for a power light, looks like. Yeah, that's just for the pilot light. This. So that shouldn't affect the operation of the unit itself. The unit itself is California. That's where they designed this thing. But of course, if they made it there, it would be good. But they make it in Taiwan. Let's just hook this thing up and see if it does anything. This cap here probably is going to need to be replaced. What value is this one? I know I won't have one. I'll have to get one. 6800 at 35 volts. And what are these other ones here? 6800 at 63 volts. So 6800 microfarads. That's all it's using. But it's got two separate voltages. So this probably uses two separate power supplies. So this more than likely is a power envelope type design where it switches to higher voltage for peaks and switches to lower voltage for the lower signals. More than likely, I don't know because I haven't looked this up. But we'll hook this thing up. I'm just going to clean up this mess here on the board around this LED connector. Just take this off first of all, so that I can get some slack here. As you can see, it's bad. Camera's got to come into focus there, but got to get all this crap out. And there's a little bit of excess length of these wires. That basically glued them down to the board. What we don't know is this electrolytic that's leaked out of the capacitor, or is it just something that was spilled into the top of the unit and stuck on the capacitor? I guess if we pull the cap off here, we can see whether anything's leaked out of it, and indeed it has. This cap is shot. You can see that the top is popped on it. That one needs to go. That one needs to go. And probably these two here also should be replaced. They don't appear to be bulging, but definitely these two need to be replaced. So they will be getting swapped out. And possibly these other ones too. Let's just take a look at these ones. Let's see what shape these ones are in. If I'm going to replace a couple of these on a sub amp, we might as well do all of them if they all are bad. These other ones here probably okay. But if we pop the top off here, we'll see that this one's fine. There's no leakage here whatsoever. Top has not been popped on this. These two are probably okay. It's just going to be, well, this one really is the one that's bad, but the other one here should also probably be replaced as well. But we'll take a look at this other one. While we're at it, see, when they start to leak, yeah, this one's bulging too. You can see it. When they start to leak, they got to be changed. It's as simple as that. I want to see if this amp actually works, though. See if there's anything else wrong with it before I make a trip in and try and get some caps for it. Not try to, I'll be able to get these. They're pretty standard capacitors, so that's not going to be an issue getting the parts for it at all. But I want to make sure I don't need anything else before I go down that road. Okay, it works. I'm turning the frequency down, increase it so we can hear it, and of course the volume. Turn off the power. It should shut the power off going to the preamp as well, I think. There we go. It cuts off the power feeding through to the preamp. So the unit, it's working. I just need to get a couple caps for this thing, and that should get this thing working like new again for several more years. In order to access these caps, we got to take the whole unit apart. That requires taking the base piece off, the base back panel, unscrewing the heatsink, and lifting the entire board out of the unit. Now I'm probably just going to replace the two 35 volt caps that are bad, because the other ones are more than likely fine. They're not showing any sign of leakage. We'll check them out. But also, those big capacitors are expensive, and there are no stock of them. In fact, even these ones here, 6800, when I contact the supplier, I'm informed that there are no stock of 6800, and I'm going to have to go up in size a little bit, because They don't stock 6800, and they don't know when they're going to be back in stock. So here's the unit. Just want to take a look at how these caps are configured. I think they're on, yeah, they're on separate. They're on separate power supplies. These are the ones that I'm going to change out here. I'm going to leave the other ones as they are. We can test them just for capacity and for ESR, but I think the other ones are okay. So we'll remove them and test them. Just so you worry warts out there that are concerned about charge capacitors, there's no charge in any of them. Everything's dead. Which they should be, because any half-decent design of any equipment is going to have internal discharge resistors to actually discharge the voltage. But if we look at the path of the outputs, it looks like no, the higher voltage rails go to these smaller transistors here, and the lower voltage rails from these capacitors are going this way. So, like the NAD, the larger transistors are actually feeding off the lower power supply. The higher power supply transistors are the smaller ones because they're just used for the dynamic range extension, which would explain why these smaller caps, the 35 volt caps, are in the shape that they're in, because they're the ones that are being used the most. The other ones are just charging up and holding a voltage, but unless it's something very loud which requires the higher voltage helpers, basically the secondary output transistors, these ones here are not doing much. So this is exactly like that NAD. It had a low voltage supply, higher current, low voltage supply for the main power output that's running all the time, and then when you need that extra power, they kicked in the other transistors, which would be just sitting there in series to provide that extra higher voltage when necessary, so they could kick the voltage up. If we remember the schematic from the NAD over here, right? This is the schematic from the NAD, and this is going to be very similar. I don't have a schematic for it, but I can pretty much assure you that the design of this amplifier is going to be very similar in design, where you've got two sets of outputs. You've got one running at the higher voltage and one running at the lower voltage, and the majority of the time all your sound is being drawn from the lower voltage transistors, and when extra power is needed, the higher power transistors kick in just to give you that little extra power for that extra dynamic range. That would make sense why these lower voltage caps are the ones that are leaking, because they're the ones that are taking the brunt of the filtering. Here's one of the 6800 63 volt that I'm not going to replace because I think these ones are fine. We'll just take a look at these capacitors in capacity mode. So negative terminal and positive terminal. It's going to take this thing a while to charge up. Oh, might help if I'm in capacitor mode. Okay, let's try that again. There we go. 6957 microfarads. These suckers are fine. 7,000. These ones are fine. No problem. We'll check them for ESR. It's going to be probably nothing measurable. Plus the fact that these things are like 20 bucks a pop, so you know, you don't want to change them out if you don't need to. So here's our ESR on this thing. Yeah, 0.04. Make sure my leads are zeroed out. 0.02. No problem. So we'll leave those ones alone. I'm going to have to get some 10,000s for this because that's all I can get. As you can see, there's no leakage. The stuff that you see on the board that some people would say, oh, the cap is leaking. No, the cap's not leaking. It's circuit glue that they use to glue them down. that you see. But the other ones definitely were leaking. So we'll go get some new 10,000 microfarad because that's all I can get. Even they're like $10 or more a piece. So even they're not cheap, but they're certainly cheaper than these. But as I say, the larger ones are a little bit more money. Here's a couple of new caps I just got from the store here. Wonder if they've got any charge in them. I just opened them up out of the bag. These have a little bit of a charge in them. Oh, more than a little bit of a charge. Cool. I actually put my meter across them before and I saw that they were charged up to about 5 volts. So I guess from just when they were tested, or someone's charged them up and they had them in plastic bags, just awaiting for me to short them out. So first we'll put the other one back in that I removed, as there's nothing wrong with it. This was a rather unique experience. I've never come across this before. I went down to pick up the parts today because, of course, tomorrow's being a holiday, so if I don't get them today, I'm not going to get them until Thursday, and I'd really kind of like to have this out of the way, not taking up a bunch of space on my bench. So I made a special trip during rush hour to get these two parts at the only parts retailer that remains in the Vancouver area. And you know, I'm not one for, I don't line up for things. I laugh at all the people I call the losers that are standing out in front of Best Buy or the Apple stores especially. When you see people, you know, when Apple's bringing out a new phone and you see the Apple, I call them the Apple sheep, that are just standing around waiting for that store to open. I can't believe that people would actually wait for a phone and they'll stand all night. I used to laugh back in the day when A&B Sound was around. They would have their Boxing Day sale every year, and people would line up on Christmas Day. People would get there at like 9 o'clock at night, still stuck with their turkey dinner, and they'd stand out there and wait there all night for the store to open. We had the same thing go on with a few of the other, well, I mean, not just them. We got the same thing happen at Best Buy and Future Shop when they were around, and Visions. You know, Boxing Day, people just line up. And I'll never do it. I'll never go to a Boxing Day sale because I'm not going to stand. I don't care if I'm going to save money on something. I'm not going to stand in line and wait to get in. I just won't do it. And of course, since this whole COVID thing started, I've been seeing people standing in line waiting to buy a TV or something at Best Buy, you know, because they've got restrictions as to how many people can go in the store at any particular time. So I just won't do it. If I go someplace and there's a line to get in the store, I just keep on going. I'll just go to the next store. I'm not standing in line. Well, today I stood in line to get in to buy capacitors, of all things. I could not believe it. They're only letting 3 people into the store at once, and there was 25 people. I counted 25 people. I stood in line for the better part of an hour to get in. Okay, there's the old parts out. We'll get the new ones in. Gee, I hope I remember which way they go in. just tacking them in initially. I'll solder them in properly, just so they don't fall out while I'm soldering them down. But yeah, I waited 45 minutes to talk to somebody, because they're only letting 3 people in the store at once. And, you know, they got a big sign on there saying, please limit your amount of time in the store so other people can, but people will go in and they'll start looking for parts, and they'll start fiddle farting around and asking questions and just wasting time. And while the rest of us are standing out there, and it's raining today, or starting to rain, so we're standing out there in the rain waiting to get parts. Anyway, the store is going to close like in 10 minutes, and I'm still back. It closes at 5 o'clock, and it's now like it's like 4:45, you know, 10 to 5, and there's still like 3 people ahead of me to get in. And then one person comes out and one other person goes in, so now there's 2 ahead of me. And one of the guys comes out and he's asking people what they need. He's walking out and he's asking people what parts they need in the line, so that he can go and get the parts ready. So by the time I was second to go in, which is just before 5 o'clock. It was just like, I think it was between 10 to and 5 to 5. He comes out and he says, okay, you can come in and pay for your stuff now. Right, but it was ridiculous. Had I known that there would be a lineup to get in, I would have saved my time, because, you know, I'm wasting an extra hour of my time, so I should be charging the customer an extra hour of labor that I got to stand around and wait to get into the store to get the parts. I could have ordered the damn parts and paid the shipping on it and saved myself the time. Because it's an hour drive to get there in rush hour, and plus another hour standing in line to get in to get 2 parts. It's ridiculous. I'm just going to see if I can fix up that connector that's kind of exposed for the little lights. I think this is it here. I'll solder the wires back on. A little shorter now so that they aren't going to short out. I'm thinking probably these caps failed because the voltage that they were running at, they're 35 volt caps, and they're probably running pretty close to that limit. And you notice that the voltage on this is 115 or 230 volts, or 115 or 230. So we're running 120 volts here. So if this is correct, and maybe it's just mislabeled, maybe it's supposed to say 120, but if it is a 115 volt primary on the transformer, and we're running it at 120 volts, the B plus is going to be a little bit higher. So it might be pushing these capacitors close to the limit. So we might find, if I were to measure this, maybe we will measure them, see what the voltage is on the caps, because that could certainly explain why it popped like it did, if it was running a little bit hot. Let's find my power cord, and we'll actually turn this thing on and measure the capacitor, the voltage on the capacitors. So I've got power. We'll just see how close they're running these to their limit. So power on, and we are running at 35 volts. Right, that's minus 35 volts there, and this one here is the plus 35. So that's why. And then the other caps here are running at 60, and they're rated at 63. So this is why these caps probably failed, because they're running right at their limit of 35 volts. The other ones are running at 60, and they're rated at 63. So we're not over voltaging them. These are running right at the limit. Typically a 35 volt cap, you wouldn't want to run it more than about 30. You know, typically the 63 volt caps, you typically want to run them maybe 58 or so, but you're not going to exceed it. If you run at the limit, they're going to shorten the life, and if you run over the limit, you're going to really shorten the life. So that's probably why these ones failed, why this one here eventually popped, is because they are running these close, or not close to, right at the limit. That's the same thing on all those Samsung TVs, right? The power supplies that failed, and they all had the pop capacitors. It's because they were running them at the limit. You know, they're running a 5.5 volt supply on 6 volt rated capacitors. Sometimes they use 10 volt rated, but most of them were 6 volt rated caps, and they should have had, you know, 16 volt rated caps. Had they put 16 volt rated caps in at the factory, we would not have had all the ones that failed. I'm just gonna clip off the excess leads here, just so nothing shorts out. Make sure that this is discharged again. Should be at 0 by now. Yep, we're good. That one's still sitting at 26 volts. But these ones are down. Okay, not gonna touch anything with them. We'll just put the we get the screws in the back and the bottom of it, and then test the unit out. So this uses two types of screws. It uses number 1 Phillips for these self-tapping screws that go into the heatsink, and number 2 for the rest of it. These ones are relatively easy to access the circuitry on it, unlike some that require a total disassembly. Just a couple screws in the back and in the bottom, and the board lifts out for ease of service. Okay, that looks a little better. Now we'll get the top on it, hook it up, and test it. Okay, unit's hooked up to speakers, to a music source, power, and to the main amplifier to send the sound to the main speakers. Power on. Okay, gotta turn on the other amp. There we go. And the bass. See what the color of the light is when it's first turned on. Does it go red first and then green, or does it just go green? Oh, it goes yellow and then green. Okay, so it's a dual color light, yellow and green. Yellow. So once in protect, it's yellow. So both colors are working. And that's just the bass on by itself now. Okay, that's gonna wrap this one up. We'll catch you in the next one real soon. Bye for now.